All right, welcome everybody. Welcome everybody. Look, I can get really close to that camera now. What we can do today is we're not doing a whole lot of math. This question does not require math. You're just figuring out which goes in which spot in the table. So, the first 7 questions on your assignment today do require math, and I want y'all to think about those step by step, so I'm not gonna do that for you, but the answers will be posted today, and these questions, this one doesn't have the answer posted, and I'm doing this one for you here, so you can use this video to check your work on that, and I'll leave this up here for y'all. So, alright, we have a pink designer orange marble. It's in theme for Pink Day. Are y'all paying attention? Because it's kind of difficult to put this stuff in the right place. I don't know. Y'all can probably do it, but okay. So it reached a vertical speed. So okay, it says vertical. Is that X or Y?
Y.
Because I'm asking. Yeah, that was Y. It's the Y-axis. Here we go. The Y-axis is the vertical one. The X-axis is the horizontal one. So. Dang. So okay, it's going to give us a vertical thing, so it's something that's on this row. Vertical speed, so it's one of these with the velocities here. Vertical speed of 2 meters per second after. We got one of our keywords there, so we know it's going to be 2 meters per second. It's the final velocity since it said after. And it's vertical, so we put it on Y. And now we put it in the right spot. Vertical speed of 2 meters per second after falling from rest. Dang, I forgot something here. It's falling. So what did I forget? Huh? Yeah, it should be negative because this thing is falling. It's going in the down direction. So now it says it's going 2 meters per second in the down direction. Okay, we did it right now. Okay, falling from rest. When it says from rest, that means that it comes off like this without moving down at all. So that would be its vertical initial velocity. Falls from rest for 0.204 seconds. That's very specific. Time always goes in both boxes. Whenever you either calculate or are given the time like this, it goes in both of the boxes. All right. From a 0.2 meter tall table. That's a vertical measurement. So the table is at 0.2 meters tall. That's not good. Here, maybe 0.2 meters. However, again, this table is describing the motion of the marble. So the marble is not going to go up 0.2 meters, it's going to go down 0.2 meters. So just like that one, I need to make this one negative. And basically, excuse me. Basically, anything on the y-axis, on the y row that can be, will be negative. 0 is not negative because that don't make any sense. Time can't be negative because time can't have a direction with it. It's a scalar. Remember, scalars don't have direction, vectors do have direction. But time is just how much time. Time doesn't go to the west or anything. That doesn't make any sense, so that's why time's a scalar. And the last box we haven't filled out over here is vertical acceleration. Y'all know what vertical acceleration is? We got the pink designer orange marble. You know the brand Pink? Where do they make that brand? Is it even America? American? Is Victoria's Secret American?
I don't know.
Maybe it's British. Is
Got
it?
It's
It is American, all right. Where is America?
In America. United States.
Oh, I hope they got that on the video. That's great. America is the United States of America. So it's on Earth, I guess. We could say it's on the continent North America, and then we could say it's in the northern hemisphere or the western hemisphere, but that's fake. And then we can say it's on Earth. then we could say it's in the solar system. We could go on, but it's on Earth. And what's the vertical acceleration on Earth when something is falling?
Negative 9.28 or negative 9.82.
Negative 9.81, good.
81.
There, you got it.
I was close.
And there we go. Everything's negative that can be now on that y-axis. Oh, and it gives us one more thing, I think. It has a horizontal velocity of 0.6. That's horizontal, so it's x, and it's horizontal velocity. So we don't know where that goes, though. Well, let's fill out this box first. So gravity works in the down direction, right? It does not work in the horizontal direction. So it's not going to make things accelerate this way. And as I may have said before, this box will always be the same on each one. The horizontal acceleration will always be 0. In fact, all those boxes will always be the same. We're always going to fall from rest. We're always going to be on Earth, and it's never going to accelerate horizontally. So all right, now we can figure this out. If it never accelerates horizontally and the horizontal velocity is 0.6, it doesn't say whether that's VI or VF, but if it never speeds up or slows down, then if it's 0.6 at any time, before that time or after that time, it's not going to be any different from 0.6 if it never speeds up or slows down. So this horizontal velocity will always be the same here and here, because that acceleration is 0. Furthermore, VI and VF, because VI and VF are the same, we don't have to use one of these formulas with VI and VF in it. We can just use one with V. So when we solve for distance to fill in this box, we've got time, we've got velocity, so we can use V equals d over t and put V and t in there and solve for d for displacement. But it gives us one more thing. Check this out. It landed 0.12 meters away from the edge of the table. So that is like y'all did in your lab. If I can draw a picture down here. If here's your table and your marble does this, that distance is right here, that 0.12 meters. So there you go, 0.12 meters. So that's like the second half of your assignment, is just figuring out, where these things go in the table. We'll actually do calculations with the table Tuesday. But yeah, please start this assignment. It's 2D Motion 1. Today's Friday. And